Okay, so what we're looking at today now is 5.2, and it's called circles in the sine ratio. So our goal today is two things, okay, and it might take a couple parts for this video. So first of all, I can find coterminal angles. Obviously, we have to figure out what that means, and calculate angles, plural, given its ratio for 0 degrees less than or equal to theta less than or equal to 360 degrees. So this is a little bit different than what we've done thus far. Okay, so let's take a look. So far we've only worked with acute angles. And remember that means that we've done things that have been less than 90 degrees. Okay, so now what's going to happen is the following will redefine how we perceive any size angle. Okay, so we're going to be looking at angles that are greater than 90, even for the first part, even greater than 360 degrees even. Okay, so first of all, we're going to start by defining an angle in what we call standard position. So we have to understand where we're starting. So we call it standard position. And this means that the vertex of the angle is at the origin. So the only other time that you've heard the word origin has been with the Cartesian plane. And yes, that's what we're going to work with. So first of all, the starting arm, which we call the initial arm, is on the positive side of the x-axis. So here I have a little grid, okay, the axes, the x and the y. So what it's saying is that the vertex of the angle has to start at the origin. So it has to start at 0, 0, and the initial arm has to start here. Okay, so that is where my angle has to start. Okay, so it starts along there. And we'll just actually put that that is the initial arm. Okay, so that's our starting place. And then what happens, angles are positive if we rotate what we say counterclockwise. So what that means is I would take this and I'm going to do it in red. And if I start here and I take this and I go this way and then stop, my angle would be positive. Okay. If I go clockwise, then we would say that the angles are negative. Okay, so if I go this way around, then it becomes negative. Okay, so that's how we rotate around here. So we start on this green line that has to have its point of the vertex at 0, 0. And the initial arm has to be on this side, but I can go either counterclockwise around or clockwise around. Now, obviously, we have to stop somewhere, and where we stop has a name as well. As we rotate this angle around this initial, oh, sorry, as we rotate from the initial arm around, where the angle is created is called what we call theta, the theta and the terminal arm. So the terminal arm in this case is right here. So this here would be called the terminal arm. So where I actually have, it almost looks like an X, but really what's created here is our theta, okay? So theta, obviously this is not an acute angle anymore. It's actually reflex. Not that that matters as far as the name goes. Okay, so it means I start here, I rotate around to wherever I want to stop, and this becomes my terminal arm here, okay? And this here is my theta. Now I can keep going around. Obviously, if I'm here, this would be 0 degrees. Then I would keep going. This would be 90. This would be 180, 270, and then I'd be back at 360 again. Okay, so I'm actually going to put that there for you. Now, there's nothing that says I can't keep going around the circle. Okay, I could keep going well around the axis. It's almost like a circle. So there's nothing that says I can't go further than that. So I could go 2 times around, and then I would actually be at 720 degrees. Okay, for some reason my pen doesn't want to go where I want it to. So coterminal angles, and remember that was one thing that we wanted to study here. Coterminal angles start and stop in the same location. But the thing is, it doesn't matter how you get from point A to point B, as long as you start at the same place and you stop at the same place. Okay, so if I look at this theta here, I could keep on going around. I started in the same place. I'm going around and around and around. So this new angle, this blue one, would be coterminal to the red one. Okay, because I started in the same place and I finished in the same place. Okay, or I could have gone this way, starting the same place, and I could go around here and stop there. And so this theta here, which is different, which is slightly different than this one here, actually are coterminal. So this is the type of question we would be expected to answer. It says determine 2 coterminal angles for the following and include a diagram. So the type of diagram that we would include, and we'll do this together, would be something like this. Okay, so let's take a look at the first one. The first one says 60 degrees. Well, 60 degrees I know is in the first quadrant. So I would start here and I would finish, approximately here. It's not important that you actually get it exactly right. So that would be 60 degrees. Now, if I want a coterminal angle to that, I can either go, I could keep going around counterclockwise and create a new one. So I'll do that one in green. And so what I could do is I could go all the way around the circle once. So I've gone 360 and then stop here, which would be another 60. So one of my coterminal angles, and I'm just going to use a subscript, so theta 1 could be 360 plus the 60 for a total of 420 degrees. Now I could go around 2 times and then stop at the same location. So I could get a second one by going 2 times the 360 and then add 60. So we would be at 720 plus the 60. So we would have, and these are degrees, 780. And there's nothing that says I can't go the other way too. So I think on the next question, I'll go the other way just so you can see how I could have negative coterminal angles as well. Okay, so let's look at the next one. The next one says two coterminal angles for 210. Well, 210, let's see, where would 210 be? Well, this is 180, so 210 is in here somewhere. So again, I'm going to take, and we'll do it, I suppose, in orange just to have some fun. So this is where I'm starting. This is where I'm going to finish, okay? So that is going to be my theta of 210. So that is 210. Now, how about we go back this way? Okay, so that we have a -1. So I could go this way. Now remember, now I'm going negative direction. So what would that one equal? Well, let's take a look. All the way around this way would be negative 360 plus the 210. So negative 360 plus the 210. So we could have a theta 1 as being negative 360 plus 210. Okay, and obviously I'm going to have a negative value here. I'm going to have negative 150 degrees. So that means that this angle here is negative 150. Okay, which isn't a problem. Now, it gets kind of messy with our diagrams the more times we go around. Now, this time I'm going to come up with another positive one because they're actually easier to find. So if I start here and I go all the way around once and then stop at the 210. So this time I'm going to do it in blue so that it's a little bit easier for us to see. So again, I'm starting in the same location, but I'm going to go around one revolution completely. So I'm at 360 and then, sorry, 210. Isn't that a lovely circle? Not very much. That's what happens. Technology doesn't work quite as good as actual people. Okay, so that one would be 360 plus the 210. And what we end up with that is going to be 570 degrees. Okay, so the angles start in the location, they finish in the same location, but how they get there can be very different. Okay, so there's infinite answers to either one of these. Okay, so let's go on to the next part. Let's see, I think I'm going to pause the video now, and then we're going to see what this is all about, because the diagrams changed just a tiny bit.